Welcome back. Let's start with some basic examples of DES simulation. The first example I'm going to cover is of a warehouse where we will store pallets for shipping. And before starting, I want to make one important point on the usage of generators. And generators are similar to functions, but instead of returning the whole value at one time, there is a delayed return, meaning that a part of the state of the variable is returned, and this is usually achieved using a yield function. So for example, we have a function, let's say define a function of x, and let's say this return x square. So for generators, instead of return, there is a yield statement, which basically signifies that there is a delayed return on the state of variable stored within this function. And this is very useful if we don't want to return everything at once, but we want to build some sort of counter inside the state of the function, which will keep the track of how many times, let's say, we are yielding a value. So this makes it quite easy to build things like counters or things which can be used to generate events because of this delayed return functionality. So now let's look at this code. So this is a very simple example where we are just using a resource or two resources to basically take hold of an entity for a certain time period and then release it basically. And the loop of the program starts from here where we'll just put a while true, so it always runs a while loop. This is similar to the for loop which we have seen in the earlier programs. So we'll start off with three basic processes or sub-processes within this code block. So we have the unloading of the pallet, we have the processing of the pallet, and loading the pallet for shipping. In each of these, we'll use the yield statement like we saw for returning the state of an object over a period of time, since this is a simulation. And we will use timeout functions for the environment to hold this for a certain period, which is given by the time property which we have set as part of our simulation baseline, which is here basically. So you can see that the whole thing is actually running inside this environmental object, which takes into account this whole process function, and this controls how the simulation is run and for what period of time. So the output is basically here, and you can see that the events start to unfold here. So we have the unloading at 0, unloading at 5, and this is just the timestamps which are recorded by this simpy environment object, and it runs for a duration of 30 iterations. So we have unloading at 5. So these are two resources whereby we are having a certain stochastic nature in the simulation itself at this point. So our processing of the pallet is a random event, so it can have this random distribution from 1 to 3 basically. And overall, this is a very simple simulation because it generally consists of two resources, let's say resource 1 and 2, which are taking these entities, processing it under this particular generator yield function, and then return it outside the simulation object. So once again, to do this, we will generate the simpy.environment object. We will create our resources. We will put the initial parameters of unload time and load time. This is basically deterministic, so it's set values instead of distribution. And then we will iterate it over 3 pallets in the system. So the result will be something like this. And this is a very simple example, not very helpful, and we probably will need to build more complexity on this to be able to use it in the real world scenarios. Now let's take a look at another example, and here we have once again of a customer entering a service area and then exiting the simulation. So we'll model the inter-arrival time of the customers at what inter-arrival time they are basically arriving at the service area, the processing time of the service area, and then they are leaving the particular simulation object. So here we have two functions. We have a function for the resource, and here we have a function for the customer generation or the entity generation. And this function basically starts with taking into the account of the time which is at the starting point of every cycle of the inventory or environment iteration. And here we request the service text resource, so wait until the resource is free, and then we sort of serve the customer based on the service time defined in the parameters. And the customer generator function basically continuously processes the generation of customers based on the input distributions of the inter-arrival minimum and maximum times. So basically we'll use a uniform random distribution, and a uniform distribution is a family of distributions which basically generates values from the minimum to the maximum value, providing the same uniform weightages to all the values within this interval. So it's a random distribution similar to the normal distribution which we have seen earlier. And finally, once we have defined our customer information and the distribution, we will run the simulation process using this particular API. So here we are invoking this function which will be running inside this particular process. So to start the simulation, we will first again define our SIMP environment object. We will create a service desk resource with a capacity of 1. So only one customer can be served at a time. And then we will define our key parameters, for example, inter-arrival minimum time, inter-arrival maximum time, service minimum and service maximum time. And these are basically key parameters for creating the uniform distributions. And this is the iterations which will be run. So it's representing one iteration is about 1 minute, so it's running the simulation for 50 minutes. And this particular command will set up the simulation for running. And the output you can see here will be shown as the output log with different customers and the timestamps showing. So how is this useful? Well, we can model our customer functions and the service desk functions based on our real world scenarios. So for example, we can model the inter-arrival time based on the historical data which we have collected on the customers themselves, and then based on that we can run analysis to understand how does the customer's waiting time is impacted by the different resources which we set up in the process itself. Now let's look at another example for inventory, and this example is still simplistic in nature, so because we are just discussing the basic aspects of DES, I have created a simpler example for inventory. And very similar to the examples before, we define a generator function to model a process, and within this process we will have code blocks for sub activities of the process itself. So our entities can be the inventory levels and the daily demand, and our resource will be the supplier who is supplying the items once the reorder point has been triggered. So just a quick look inside the function itself. So it starts with the initial level, and then basically we'll create a while loop which is always true, and then we'll check up the starting level of the inventory, and then we just check the demand itself. The level has hit the point for which we need to reorder, and if we want to reorder, basically we will use once again the yield function to model the resource, which is the supplier here, based on the lead time which we will provide at the start of this simulation. So basically the supplier will hold this particular entity for a certain time. Upon re-releasing it, we will add the reorder quantity to our inventory level. So let's see how it works. So initially we set up our parameters, and once again we create the environment object. We start the simulation process, inventory simulation process, and then we run the simulation for the set number of cycles which we have defined here as 10. And similar to previous approaches, it starts with the initial inventory, and then based on the demand which we have set here, it starts decrementing till and it reaches the reorder point where we are generating an order of 50 units, which is basically this part. And then based on the lead time which we have set, it will take that particular time and then of lead time basically, and then add that inventory stock to our current stock based on the reorder quantity. So in this lecture we have looked at 3 examples of applying DES to real world scenarios. We have seen how we would go about creating the environment objects, processes, generator functions, how we will set up our entities, how we will set up our resources. And in the next lectures we will take this forward and we will start applying this in detail to our inventory models.